Okay, so this is the Grasshopper 101, the first lecture, first demo about how to use the plugin for Rhino Grasshopper. So first thing I want to do is after install the Grasshopper, you can just type Grasshopper, right, in the command line. So if you open this new window, this window has pretty much organized based on the geometry. So if you look at the tag, it has the different groups, vector, curve, surface. So really depends on what kind of geometries you loaded into Grasshopper. You can always go to these manipulation groups. You can see a lot of tools available here. Also, I want to show you is in the future, if you installed additional plugins for Grasshopper, for example, Lunchbox, Kangaroos, these are all pretty interesting plugins. I think LGA can help you to do the installation if you have trouble. This will show up in the tag. So this is basically additional cool stuff you can get beyond Grasshopper. So I do recommend, there's a pretty good package, you guys should all get it. One is the Lunchbox, which give you a lot of paneling, tessellation options. Another is a Wavebird, which handle the mesh geometry very well. Okay, Lunchbox and the Wavebird. So this is the two important ones. In the future, if you're interested about other stuff, just let me know. We can definitely give you more options. So like a paneling system is actually quite interesting. Kangaroo is quite interesting too. But anyway, let's start with the really basic one. The first group is this kind of hexagon shape component. These components allow you to make connection between Grasshopper to a Rhino geometry. So for example, I want to create a simple curve in Rhino, right? So let's do that. I will create a rectangle, and this is a curve. Actually 4 curves, right? So in order to loading this guy into Grasshopper, you can go to the geometry and then choose curve right here. So put that here. So this is the first component you made. I do want to show you in Grasshopper, you can change display from icons to name. Usually I will stay with icons. Just easier I can remember. I'm not that sensitive to the actual name, so you can choose draw icon option. Okay, so this is the component curve. Right now you'll see this kind of orange color, right? Also you have a tag. If you roll over your mouse, it tells you what's the problem right now. Is this is empty, right? There's no content within this collection and within this component. So what you need to do is right-click. You can set one curve. So this pop-up menu gives you a lot of additional options. I can set one curve. Then I pick up this rectangle in Rhino, right? Then you see it's changing color. So color will help you to kind of diagnose if there's any issues, problems, or missing content for Grasshopper. So right now it's gray is happy. So gray is happy, I think. All right, so we have this curve. Then let's do something pretty fun, and let's see. Maybe first I want to just fill some points within this curve, right? So if I go to vector, so see some populate 2D. This is an interesting component, so let's just using that to test. So I click this guy, put it here. So that's a new component show up. Another way you can find the component you like is search. So if you double click the empty place, and if I'm interested about 2D stuff, you can type 2D. Then it populates all the possible components related to 2D. Right? Then you can say, well, I want to do populate 2D. So that's exactly this guy. So double click, then you can just search whatever name. So if I want to do, I don't know, surface related, if I type surface, This is all surface-related components. Okay. Anyway, I'm pretty happy with this kind of 2D populator. So let's figure out what exactly these do. Right? So whenever you have a new component, you have no idea how to use it, right-click, click Help. Right? That will tell you what you can do to input and output. So Help. So tell you for the input parameters, you have R, N, S, P. So each one represent some data type. So R means rectangle, N means integer, S integer, P points, right? It also has output, is points. So I can see on the left is input, on the right is output. So let's try that, all right? So I want to actually plug in my rectangle. I'm going to plug into the R because I know R is a region, right? So just plug in, drag and drop the connection. So boom, you see all the points will automatically populate this rectangular square. So if I move the square, all the points go with it. That's pretty cool, right? You got the first component working. You might also wondering, well, what is component name of N, right? N is a number. If you roll over, you see it's default as 100. So if you do not give any input, that's the default value. However, I do want to give a different value. Let's give 500 points. So the best way to put a value in is give a slider, so I can later manipulate the numbers. So double click, I'm typing slider. Okay, so see this number slider show up. All right, so here's my slider. Slider right now is floating points, right? But you see here you need an integer. It's how many points you want. You cannot give a half points or quarter points. So first thing I will do is change the numbers. So double click the slider. Then I can change the slider from floating point to integer, right? I can also define the range. Right now it's from 0 to 1. Let's double click. Let's give, I don't know, 500. Okay, click OK. So now I can drag the slider. You'll see the value change. That's how you define the number. Okay, so after we have the number, things became pretty simple. I just drag this guy, plug into N, and you can see there's more points show up. If I drag it, you see more or less. Pretty nice. So this is how you work with Grasshopper. Just consistently build up relationship between geometries. Okay. I can give you another demo. It's actually quite useful as well. If I want something a little bit regular, it's not like a random numbers, let me just disable this guy. The way to disable or hide the geometry is use middle view. Okay, if you just one click, you can see these pop-up wheels. Then you choose this guy to hide. It looks like a blend. Or you can choose this one to disable. Disable is very simple. Like in AutoCAD, you can freeze a layer, right? So basically, it will eliminate that operation from the memory. So here the same. You can disable that. It doesn't calculate. If you only hide, that component still in the calculation, right? So that's the difference. So right now, let's maybe just hide it. So you see this turns to gray color. So now I'm going to actually create a surface. So if I go to surface, this is all the surface related tags. So let's see, probably I want to do a boundary surface. Let's just play with it. So click that, put it here. So now the boundary need an edge, right? And this rectangle shape is an edge. So I can just plug in that. Right, you got a surface. You see the color is being filled. That's pretty easy, right? And then I'm thinking, well, after I create this surface, maybe I want to divide the surface into, patches, small sections. So I can divide the surface, put this component there. So you consistently build up, more components. So here I have no idea, what this SUV means. And it seems like a car, right? So I go to, help. Then here we go. You see S means surface. UV is actually two values. You control the number of segments. How many times you want to divide the surface. So always go to help. All right, then I'm going to plug in the surface in. Oh, by default, you see the points show up, right? The reason is it has a default 10 as a default value. So again, if I want to give a different value, I will just Control-C, Control-V. I copy-paste this slider, so I don't have to start from scratch. Let's give, 16. And I plug in that to U, plug that to V. So you can have the same. Oh, that's too dense, right? You can control how many points you want to populate on that surface. Okay, so this is the whole process. In Grasshopper, you build up this parametric relationship. One thing I also want to show you as an intro video is the way you can highlight the component. On this side of the screen, you see this green color bucket. Right? It looks like a cylinder, right? If you click that guy, Grasshopper will only draw the geometry based on your selection. Okay, so if I have nothing selected right now in my screen, you see in Rhino it doesn't display anything, right? It's nothing there. However, if I select this component, right, which is green, you see Grasshopper will force this component to be displayed in Rhino. So it's very, very useful. By this way, you can easily just go through. I want to know what this component do. I just click that. As soon as you select this component, Rhino or Grasshopper will display the result of this component. If I select this populate 2D, see, really depends on your selection. The display is different. That makes sense? So this green color bucket, this cylinder is very useful. Okay. So next one I want to show you is how you can copy paste the definition from other files into your file. So because we are not going to reinvent Vue every single time, there's a lot of definitions available in my library and also in the Grasshopper 3D website. You need to know how to use it. Okay. So first one, I'm going to show you. For instance, I'm really interested about using, one geometry. Let's see, I'm going to create maybe a circle, for instance. I want to use this circle to populate every single point. So there will be a duplication to every single point. Okay, so if I want to do that, then if you open my example files in the Dropbox, the name is a pattern, you will see, well, Ming already did something right here. It's pretty interesting, but it seems like it's missing some content. All right. So what you can do if you want to use this stuff in your file is you can copy paste. So I will copy this file. You can use Control-C to copy. Okay, Control-C. And then you can switch back to your file from this corner. What's the file I just made? I think it's this one, right? Yeah. So this is my file right now. So I can Control-V to paste. Okay? So it's nothing wrong to copy-paste from others. I mean, in today's parametric design, it's very important you learn collectively. You know how to read other people's minds. So copy-paste from other files. Okay? So as soon as I paste this file, I can somehow digest the logic. Right? See, right now you see, well, all the code is dark gray. That means the code at this point is disabled. So if you select them and use middle view, you can enable this. Okay, so sometimes you have to do some kind of tweak in order to make it work. All right, so all the code is active now. Then you see orange color. Do you still remember what's the meaning of orange color? Why is orange? Any ideas? Well, it's not connected to the content. Yes, so it's missing the content, right? Most likely when you copy code from others, this content is pointing to some other geometries which is not in your random file. It not exist. So you can see the logic of my version is very similar. I'm going to populate a region, right? So this is kind of the curve, define the region. So I'm going to actually use my rectangle as a region. So right click, set one curve, and that's exactly the same. I pick up my rectangle. So now it's turned to gray. It has the content, right? So your goal is make sure every single orange color has relinked to some meaningful geometry. All right, so now if I select this, wow, it's populated, right? You know this is working. Then you see another orange show up. If I roll over, it's a curve. Right? So I'm not exactly sure what these do, but let's do a test. Right? I'm going to right click, set the curve. I'm going to set into this circle, yes, to test what's going on. As soon as you set to the circle, if you go through this component, you see this script using this guy, the name is area, to detect the centroid of that circle. Okay, still I have no idea why this is working. So let's just keep going, follow these wires, right, from left to right. So I know the next one is orient. So let's click that. Suddenly you see something pretty interesting happen, right? Is every single point. Let's make the circle smaller so it's easier to can see. Scale. Oops. Yeah, I just make the circle smaller. Oh, there's a log. Okay, I make the circle pretty tiny. Easier you can see. So now if I click this component, orient, still pretty big, but you got an idea. Every single point, it will duplicate this circle to that point. Right? So see, well, that's the function for this component. Again, you can right click, check the help. It will probably tell you what this component do. So you have a base geometry, you have A is the initial plan or the initial location. B is the final location or the target location, right? So in this case, you can see the initial location is a centroid. Makes sense, right? The target location, if you look at that, is every single point from this surface. That's the reason you see the circle is populated directly there. So let's do a test. If I make the surface really big, you can do all kinds of tests. If I make the surface really big, yeah, you see it's automatically, still it's automatically populate whatever, surface you have. And also I can see, well, if I change the number of UV, well, still populate, right? Depends on how many points on that surface. If you click, this is control how many points, and then each point is populated with a circle. If you think, well, let's test if I have a random points, right? If I plug in the random points as my target, then you see the circle as random, right? Well, I can also test how many random points I want to have. So I can reduce, I can increase. You see the update. Okay, so this is how you somehow, I would say, borrow the script, or steal the script, whatever, from other people, and then you can use it for yourself. Okay, so that's how to speed up the design process. All right, so I'm pretty happy with. Let's back to the points, the surface points. Okay, So I'm pretty happy with the surface points. However, I want to use, for example, happy face image to control the scale of the circle. Right? So the circle will be different, depends on the different location. And that script I'm not going to write from scratch, so I know it's somewhere in the library, because I built a library. So I will point to you how you can, easily grab the things from the library. So here is one example. In some other tutorials, usually I will break down what that tutorial do. For example, in this tutorial, I use Congru to do this tensile structure, which automatically deform based on the physics, which is nothing to do with our homework. But you can see in step 3, this is the definition on the Grasshopper file. Use the image to control the pattern. Okay, so you could actually just download the file, take a look. So I will go ahead and save the link. So the map 2D, 3D, I think I already have that. So let's open that file. So file is map 2D, 3D. All right, so that's the file looks like. Of course, there are some orange color, it's missing content. But you see, the idea of this file is it can use an image, and then the image will generate something. Later, it will scale up and down. Right? So this component scale. So without knowing the details, I can just copy paste the entire thing. You can treat this as a black box. The black box has input and output. You only need to know what is input and what kind of output it produces. You don't have to worry about what is inside the black box. I mean, in some way, you can just understand the in and out. That's it. Right? So here I'm going to grab it, Control C, copy, and then I can go to my file. So this is my current file, right? That's all the circles. I'm going to paste. All right. So I have this black box, come in. I know this black box, if I zoom in, it seems like it defines number 1, like a boundary file. Right? This boundary file is being, linked to create a surface. Also, it seems like it input a sequence of curves, and then the curve will be detected to a center point. Then the center point will be pushed into this image. So let's just worry about this input. All right. So I know this part is sequence of curves. This is one single curve. Okay. So for the sequence of curves, I will do this circle because I have 625 circles. Right? So I will plug in this circle into this black box. All right. And here in this one, it needs a boundary curve. So I'm going to use my rectangle. So this is my original rectangle. I plug in that into this black box. Simple like that. Then you see everything turns to gray. That's good. If I look at my final result, the scale, did you see the match? Right. This is a gray color image. And the circle will be scaled. Depends on the black and the white. Okay, so that's how you can just plug in other script. If I'm not happy with this image, again, I can double click. I can swap to my own image. That happy face. Right? If I click OK, and then select the final result, you'll see that happy face show up some way, right? So here's a eye, mouse. Probably I think we can make the circle bigger so it's easier you can see, or you can just simply increase the density of points. So if you make the density really high, it's pretty easy, you can tell. Okay, so this is how you grab script from others. If you don't want like the circle, you can do hexagon, right? you can use a hexagon to replace. So here, that's an initial circle. So I will right click, set the curve to hexagon. Then you see the result will update in no time. So this is not circle anymore. Right? So that's the beauty about parametric design. It's an open system. You can plug in many different stuff. All right, I will save the file. I will give the file to you so you guys could definitely play with it. Again, the file is actually already saved in the Dropbox, so later make sure to download. Let me see anything else. All right, I think that's a pretty good intro. Let me stop the video right here.